I'm Kirk Harnack. On This Week in Radio Tech, I'm joined by Tom Ray, Chris Tarr, and Marcus O'Rourke. And we talk about balancing crazy work hours and home life, building radio station studios in Afghanistan, and AM field strength readings. Twert is up next.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for This Week in Radio Tech is brought to you by Cachefly at CACHEFLY.com.
This is This Week in Radio Tech, episode 85, recorded June 1st, 2011, in the field. This Week in Radio Tech is brought to you by Axia Audio and the new Radius IP audio console. Feature-rich, affordable IP audio consoles from Axia on the web at axiaaudio.com. And by Trim Tonic. Trim Tonic is a natural appetite suppressant tonic that takes the edge off being hungry. Go to trimtonic.com and use offer code TWIT for 20% off. Hello, it's time for This Week in Radio Tech. I'm Kirk Harnack. I am so glad that you've joined us. I really am, because without you, we wouldn't have any viewers or listeners. We are live on the twit.tv network right now. You can also get this podcast, as you may have, by downloading it through iTunes or through the twit.tv website. Any number of different ways to get it from different RSS feeds and feed burner type services and just all kinds of places. So wherever you find it, we're glad that you did. Hey, you can also pick us up on your Apple TV. I was sitting down with the family watching Apple TV the other night, and we just watched about 20 minutes of me. And you can also find it on, you can also find it on your Roku box. In fact, I need to ask Chris Tarr how to do that. So I'm Kirk. I'm the host of the show. I work for the folks at Telos, Omni, and Axia, who are also sponsors of the show, and we're glad you're here. We talk about everything that has to do with audio and radio and transmission and, funky propeller head stuff like that. We try to keep the audio headed to the listeners. Radio is still the most popular way to hear audio, especially in the car. Joining me tonight on the show, as usual, from the Hudson Valley of New York, it's Tom Ray. Hello, Tom.
Greetings and salutations, Kirk. I'm a VP of Engineering at Buckley Broadcasting, WOR Radio in New York, and based on tonight's topic, it's really good for me because a lot of people say I should be outstanding in a field someplace.
Tom, you're kind of like not featured on tonight's show, but I know you'll have plenty of comment because the things that Chris Tarr is going to talk about, you've done plenty of. Speaking of Chris Tarr, let's bring him in from Muckwonago, Wisconsin. Hey, Chris, good to see you.
How you doing, Kirk?
I'm live. I'm jazzed. I'm excited about the show tonight.
Well, it should be a lot of fun. I did spend some time out in the field. I can't wait to talk about that. That's always fun, especially now that we finally got some nice weather. I am the Geek Jedi. I'm the Director of Engineering for Intercom's radio stations in Milwaukee and Madison, Wisconsin. Basically, I'm a wrench. I also do a lot of online stuff, and you can find out all about me at geekjedi.com.
All right. And also, before we end the show, Chris, be sure you mention your website for engineers to go get information. And speaking of engineers, another one is joining us for the first time on the show, and maybe he'll come back again if we like him enough, from Santa Ana, California. It's Marcus O'Rourke. Hello, Marcus.
Hello. Good after evening or whatever it is, kind of in that in-between time.
Tell us a bit about yourself. And you and I, have we met in person? Have we shaken hands at a show or something?
We've, I think it was last year. Yeah. It was real brief, but it was because it was busy. But yes, we've met.
Well, I've seen your name around the company I work for, Telos, because you've got some Telos and Axia gear out there at your place. Tell us about Marcus O'Rourke and what you do.
Well, I am the not chief engineer, not director of engineering, but one of the main engineers here for Calvary Chapel of Costa Mesa, and we own 4 radio stations, mostly in Southern California, and a satellite feed network that feeds affiliated stations. So I keep busy with that. I do the, what is that? Brain just went on vacation right now. EAS committee for Orange County. So, yeah.
Hey, well, in fact, Marcus, you've got a topic that you're going to be chatting with us about here on the show. In fact, we're going to do your topic here during the first segment, but I wanted to bring up a topical thing. Well, let's see, a topical thing, and that is some folks have been asking about this report from the World Health Organization about cell phone RF radiation perhaps causing cancer. Now, you know, for years we have seen one report after another. Cell phones cause cancer. Cell phones don't cause cancer. Cell phones cause cancer. Cell phones don't cause cancer. And look, we're not experts on health here, but at least I thought we'd weigh in a little bit about what it is that cell phones do that might cause cancer. You know, most folks realize, well, they're putting out some energy so they can talk to the tower, right? And maybe we can talk for a minute about, you know, what kind of energy that is and what the level is and then that kind of stuff. Chris Tarr, you're a guy who's somewhat health conscious, especially in terms of RF. What do you think about this whole issue of cell phones and causing cancer?
Huh? Oh, sorry. You know, I have to say there are people much smarter than I am that are solving these issues, but you know, on the surface of it, I'm not a big believer in it. I think that you know, all the years that I've been around various types of RF, you know, I certainly think there's some danger with tissue heating and things like that they've been talking about. But as far as a cancer risk, that seems a little off to me. And you know, again, not being a scientist or in the medical profession, I don't know that I don't speak from authority here, but my inkling from having been around RF and knowing what it can do, you know, I'm not sold that that's really going to be the issue.
How about you, Tom? What do you think about cell phones and cancer causing?
Well, from what I understand about how RF works and such, it causes heating. Which, what I've been told, I've had several RF safety training classes, and what they said was it causes heating. Now, the heating itself does not cause cancer, but it could cause a change in the cell where that could eventually mutate. Personally, I think the risk is rather small. I mean, I've been working around RF for 34 years now, and know quite a few engineers who are well up into their 90s who used to climb AM sticks when the transmitter was hot, and I'm talking 50 kilowatts. So, I don't know. I mean, there might be some remote link there, but and like Chris, I'm not an expert, but
and your uncertainty about that too is. Your uncertainty parallels the uncertainty in the whole medical community, and certainly there's anecdotal evidence one way or the other, and usually it's the one way. Usually, if there's anecdotal evidence, hey, my husband died of cancer. The cancer was on the left side of his head. He always held his cell phone up to the left side of his head. So you know there's correlation, not necessarily causation, but there's correlation. So there's plenty of there's plenty of correlation, but I guess it's causation we're looking for.
And I also think that there's so many factors that play into that. For example, modern cell phones, their power is regulated by the base station of the cell that you're talking to. So, for example, if most of the time you're right outside a cell phone tower right nearby, the power that your cell phone is transmitting is very, very little. I mean, it's very little power, milliwatts. So, you know, I seem to think, you know, there are things, I can't think of anything that's perfect for you. You know, everything is going to, you know, I couldn't find anything that couldn't cause something. So, you know, there is something to that, as Tom was saying, with the physiology going on and the heating and things like that. But I think that there are so many things that have to be right for that to happen, I guess, is where I'm getting at this. I mean, you know, yeah, if you held the phone up to your head for hours a day and your phone was transmitting at full power and you didn't move it from side to side and you didn't use a headset and all these different things, yeah, it probably could cause some problems.
Marcus, do you guys out in California use headsets? Use cell phones?
Oh yeah, cell phones are a very big part of our lives here. So I've racked up many minutes on my phone.
What's your take on this story? And do you, somebody in the chat room mentioned a headset. I'll take this moment to mention that, you know, the power from any RF source decreases. It decreases by the square versus distance. So if you move a cell phone, you know, some distance away from your head, the power goes down by 4, and again that same distance again by 4. So the power can really go down if the cell phone is just a little bit ways away from you. So if you're concerned about that, use a headset. Use a Bluetooth. I mean, the power in a Bluetooth headset is nothing. Or use a wired headset if you want to do that. Men, but if you're using a wired headset, where do most men put the cell phone when they're driving? On the seat, between their legs. Not sure I do that. You know, There's a cup holder there, or the armrest in the door. Use that. I'm sorry, Marcus. Go ahead with your thoughts on this subject.
No, I agree. There's I find it very interesting that people would say that it's causing cancer, but again, I'm not a doctor, so I haven't done the studies, but I don't believe that it would cause cancer personally. But that is my personal opinion.
Who else was going to jump in there? I interrupted somebody.
Kirk, many moons ago, I worked in cellular for about a year, and this was the time when the cell phone was almost shoebox size, and those little portable phones ran at 5 watts. I mean, the phones we use today are lucky if you get a half watt out of the thing. So the power levels are significantly lower. We're also using a different frequency band. The old ones used to be between 800 and 900 megahertz. New ones are up around 1.8 gig, or 1.8 gig. So, the frequency band is different. The power is a lot lower. And Chris Tarr is right. There's a lot of factors going on. Matter of fact, I lived someplace once. We had a cell tower going up the street, and I was out of town. I had built a radio station. I came home, and I'd been out for a couple of weeks, and I came home, and I said to my wife, "Oh, they're building a cell tower up the street." It was about 3/4 of a mile from the house, and she went, "Where?" But I'm up on the roof cleaning gutters one day, and this guy comes up, and he starts yelling about something. I look down and I said, "Well, what do you want?" "I'm cleaning the roof." And he says, "You know what they're doing up the street?" And I said, "Yeah, they're building a cell tower." He goes, "Do you know what that's going to do to you?" I said, 3/4 of a mile away? Probably not a darn thing. Last
going to give me better cell phone reception is what it's going to do.
well, his sister lived in a house very close to the base of the tower. When we moved out of that area, last I knew, she was looking for copper paint to paint her house because she was scared to death of the radiation. And it was like, you get more radiation out of your TV, lady, really.
Yeah, that is so true. And this World Health Organization report also suggested that that schools not have Wi-Fi in the school because of the RF radiation and the possible link to cancer from Wi-Fi. Really?
Yeah, I think that's just crazy. I think that's insane. I mean, there's a line between real science and junk science, and that's way over that. That's not only stepped over the line, it went 3/4 of a mile down and then took off to the left. I mean, it's insane.
Well, we could talk about this all day. We are talking about things that are out in the field, which seems to be the theme of our episode today. Hey, let's go ahead and talk to Marcus for a few minutes about what he wanted to share with us, and has to do if you're working out in the field in radio, I bet you a lot of time goes by. A lot of time goes by when you are working for your employer, or if you're a self-employed contract engineer working for yourself, and that is how to balance all the work you got to do at the radio station versus your home life. And that's something that we really haven't talked about here on this show. So Marcus, come on in and tell us your thoughts about this. Kind of set up the notion. I mean, hey, we're all engineers, and sometimes we got to work crazy hours. We had calls in the middle of the night.
Maybe Marcus can identify a home life for us.
Yeah, tell us about that, Marcus.
Yeah, home life. No, it's something really, really tough, and I've noticed a lot of friends in the industry that I've had and friends in other industries, they'll get so caught up with what they're doing that their wives or their families won't see them maybe for an hour a day, and what does it get them? Yeah, they're getting a lot more money, but in the long run, their kids are missing them, and I think in the long run, family is a lot more important than, having stuff personally. But
well, that's easy to say. How do we balance that in a life where where we have things like medical bills? I mean, I just got a bill here from Vanderbilt Children's Hospital for $10,000. We got to make a dime to do these things, and I hear what you're saying, but kind of help us understand how you really put that into effect.
It's tough. Sometimes it could be as easy as saying no, but I know at times it's not easy to say that as well because of the bills. But, we can push ourselves, but if we don't say no sometimes, if we don't say, can this wait until tomorrow, you're going to end up on your back in the hospital, yourself needing more medical bills and not able to pay the bills.
Now, you bring up a good point, actually, because so many engineers, and I'll bet you I speak for Tom and Chris, too, on this subject. We get a charge out of being needed to solve a problem and going and solving the problem. And honestly, there's a lot of engineers out there who are pretty darn good at solving problems. And they like to put that to use, kind of like an emergency room doctor or an emergency room nurse. You get that adrenaline rush from being needed, solving the problem, being the hero at the moment. Tom, Chris, you guys ever suffer from that like I have?
Oh, absolutely. Well, I actually this past year I started to burn out, as you know, between Twirt and writing for Radio Guide and all these radio stations, and I have a lot going on, and I do a pretty good job of juggling that with having a wife and 4 kids and all that stuff. But it does after a while. Marcus hit it right on the head. It's so hard to say no. When these things come up, I always want to be the guy swooping in and fixing all the problems. And finally, last year got to the point where I sat down and I really kind of had to really reassess things. And actually, my employers were very great about that. We ended up hiring an IT guy to help me out. To give me some assistance on stuff. And I started really delegating things, because I had these people who could help me out, and I kind of just took it on myself because I had the whole, I've been doing it all along. I know what to do. I'm just easier to do that. But it takes a lot to delegate and to say, okay, listen, I am going to turn the phone off this weekend. I'm not going to take the call. You guys are on your own. I'm going to have to trust you to do the right thing. And, it was very hard to do that, to trust these people. Not that they weren't, that they couldn't do it, but it was just something that I always did, and it was very hard to let that go. So, sometimes you really need to do that. So, I know exactly what you're talking about. And I think now I've struck a pretty good balance. I still carry the phone around with me all the time, and it very rarely goes off. But, I have taken some good vacation days where I haven't had to mess around with work. So it's getting a lot better.
Now, Chris, I know that with 4 kids, you're at least home sometimes.
I am, I do, and fortunately now, we have set it up where, I'm not spending nearly as much time at work as I used to, but there are still many nights where in the middle of dinner, my phone rings and I have to get up and I leave, and I don't come back till after they go to bed, and I'm on Skype saying goodnight to my daughter. So, that happens. That still happens a lot, but. I think a big key here that I really have to give credit to is my wife, who is very much, after so many years, she's used to that. And, some younger engineers, newly married and stuff, they're in these relationships, and sometimes either, man or female engineers with their husbands. It's a commitment. It really is your life, and you're going to miss things like birthdays, and you're going to miss things like family gatherings, and you're going to get phone calls in the middle of the night from strange people saying you have to run. And she's very understanding. She understands that's my job, and that's what I do, and has never questioned it, never gotten worked up about it, never gotten upset about it. And she's like, you got to do what you got to do. So I think having the support of the people around you makes all the difference in the world too.
I want to ask Tom in just a minute, but Marcus, see, Chris just mentioned something there. He used the word delegate, and a lot of engineers, certainly not all, are in a position where they could delegate. And Chris even said that he asked his employer. He said, "I need help. You got me doing too many things here, and I'm burning out." So they did get Chris some help. I've met his help, but being able to let go and delegate and say, you know what? You guys got this. I'm gonna switch off for a little while and trust that to happen. Marcus, how do you think you can get to that point where you can delegate when you've been used to handling everything yourself?
Well, I'm actually going through that right now. For the past 6 or 7 years, I have been a department of one, and now we've just brought another guy on who is very knowledgeable. He's not a radio engineer per se. He's very strong in IT, but he is learning so much, and I'm able to go, okay, you handle this. and I'll take this, and we're just dividing the work up. And I'm, again, learning a home life again. But just it's having that other person there really has helped an enormous amount. I mean, you can ask my wife, and she is so thankful that he's there and so happy that I finally have another person there to help out.
Mm-hmm. You know, you know what the tough thing I found is after, before I hired my help, I'd been there 7 years. It's really tough to let that go, because the first thing you think of is, wow, they don't need me as much as I thought.
Isn't that tough to take? Yeah.
Yeah. I mean, I was the guy doing everything, and I don't need to be here, and the place still runs. And you have to have some self-confidence too, to be able to do that. To be able to say, you know what, I'm going to delegate that. He'll probably do a much better job than I will, but that's okay. I mean, that's good. I hired a smart person, and to be able to do that and have the confidence to know that, yeah, just because that guy is better at doing that than you are doesn't mean that they don't need you anymore.
You also have the rationalization of, well, I can do it better because I know where all the skeletons are buried. I know where that relay is. I know that connection always gets a little flaky, and I just got to go in there and clean it. That's a great way to rationalize being needed.
Or even to the point of, I want it to be done this certain way. I trust the other person, but I want to know how it's done and make sure it's done the right way. But even then, you got to let go sometimes and trust the other person to do it.
Tom, you're in a situation there in New York City at WOR where you've got to trust other people. Heck, your commute is pretty far. You're a good ways from the transmitter site.
Yeah, I'm about an hour and 15 away from the transmitter site, and depending on traffic, it could get up to about 2 hours to get into the city. And but there are certain things around WOR that I've just that Tom's got to do. I mean, I'm the transmitter guy, but I have people at the studio. I have people who do IT. Tom just waved his hand. I was asked, and yes, it looks like I'm breaking up a little bit on the screen, but that's okay. But yeah, no, and unfortunately, fortunately and unfortunately, in New York City, it's such a high pressure environment because, let's face it, we're the #1 market in the country. Every station counts. There are some markets where everything counts, but it's not real hot and heavy. But I mean, if we lose, even a little bit of revenue, I mean, we've lost a lot. So you have to have good people. You have to trust them. And you have to, there are certain things that some people are better at than others, and you have to kind of weigh everybody's strengths and weaknesses, and get them all to, you get all together and make it all work.
Guys, we've got to take a break right now and hear from one of our sponsors making the show possible. We're going to continue our show with Marcus O'Rourke, who's our guest, also Chris Tarr and Tom Ray, who are regular co-hosts on the show. You're listening to or watching This Week in Radio Tech number 85. And as soon as we get finished telling you about our sponsor, Trim Tonic, I've got what I hope is a treat for you, is a treat for me to put the thing together. It is an interview with Simon Jackson, who has been on this show before. He has been in Kabul, Afghanistan, and he's been building a radio station there. Well, we've got an interview with him along with pictures of the new facilities and some of what he's had to go through to get equipment into Kabul, Afghanistan from the Bagram Air Base. So it's pretty exciting. Stick around. I don't want you to miss any of that. But right now, I want to tell you about our sponsor, Trim Tonic. Trim Tonic is a natural appetite suppressant tonic. It does take the edge off of being hungry, and what makes Trim Tonic unique is that they use no stimulants to get this effect. There's no caffeine. There's none of that funky hoodia stuff in there. Instead, they use 8 active ingredients, some of which have clinical studies that actually show their ability to curb your appetite and reduce body fat. That's a big part of losing weight and getting in shape is reducing your portions or eating less frequently or eating smaller more frequently. And so being able to reduce your appetite and curb those hunger pangs can help be part of a whole program to lose weight and get yourself in better shape. There are 3 main ingredients, and I'm not going to try to pronounce them. You can go to their website and check it out. You can go to trimtonic.com. It's TRIM toniq.com, or they have a sister site. It's under one company. There's another site called braintonic.com, braintoniq.com, braintonic.com. If you are interested in their products, and I hope you will be, you can enter the coupon code TWIT, not TWIRT, enter TWIT, this network, TWIT, T-W-I-T, and get a 20% discount. That's significant. You know, buy 4, get 5 kind of thing. So check it out at Trimtonic or braintonic.com. It really, really works. It'll make you not so hungry, make you eat less, and make you snack less, too. That's where a lot of those calories sneak in, having that bowl of cereal at 11 o'clock at night before you go to bed, or having those extra calories before you get into your good meal. Check it out, trimtonic.com. And we thank them for being a sponsor of This Week in Radio Tech. All right, if my talented producer back at the Twit Network is ready, I'm going to show you a video that I produced over this last weekend. And it's the interview with Simon Jackson. He is in Kabul, Afghanistan. Let's just go ahead and roll it, and we'll talk about it when it's done. Go right ahead. With Simon Jackson. Simon, you may remember, was a guest of ours on This Week in Radio Tech, live from the NAB show. He and one of his cohorts, Igor Zakina, was on that episode with us. Well, Simon has now found himself in... Simon, are you in Afghanistan?
Yeah, I am. I'm Kirk, Kabul.
Wow. Hey, good afternoon or good evening to you. Tell us a bit about why you're there and what you're doing there in the name of radio.
Well, we're here for a project that's actually a USAID project. They are doing talkback radio in Pashtun. And Pashtun's one of the languages. Dari is the other one. The aim is to actually have talkback radio on Arakosia FM across Afghanistan, or the northern parts of Afghanistan. So there are going to be 9 transmission sites out of brand new Axia studios, which we're building for Moby Media. And it's a bizarre situation to find a company from New Zealand coming and doing an installation in Kabul, Afghanistan for USAID. It's very strange, but here we are.
You know, Simon, I've known you for a while, and I guess I'm not surprised at the situation. But you didn't send any of your, your technical employees there to do this installation. You sent yourself. What's that about?
Yeah, myself. Well, I to be fair, someone else came with me, Rob Harling, and actually he was also on This Week in Radio Tech.
Yes, he was.
NAB,
yeah, sure.
Yeah, Rob's come with us as well. So it's I'm here to sort of hold the tools, really. He's doing all the heavy lifting.
Okay.
And I'm here just to sort of keep him company. And it was strange actually finding staff who were willing to come. Was really hard. I don't know. I don't understand why. I'm not sure. Apparently it's a great place for a holiday, Kabul.
Well, tell me about that in just a minute. In a few minutes we're going to look at some studio pictures, other pictures that you're providing. But tell me a little bit about what you can. I know there's some things you can't say, but about arriving there and your security arrangements and whatever you can tell us about building a radio station in a war zone.
Well, it's really interesting. Kabul's actually relatively safe compared to the rest of Afghanistan, or specific places in Afghanistan anyway. But still, I mean, you arrive at the airport and there are guns everywhere. I mean, it's amazing. And you get picked up, and the guy who picked us up was one of the security agents for security workers, the paid private security guards for the group that we're working for. And he's a British guy. He's an ex-paratrooper, and all his team are ex-paratroopers. And we go to these armored vehicles, and they look like Toyota V8 Toyota sort of SUVs. Until you try to open the door and you realize this door is it's about 6 inches thick and heavy. And there's a reason this thing's a V8, because this thing just weighs a ton. It is a box inside a sort of a shell that looks a bit like a Toyota. they stop and they tell you what happens if someone starts shooting at you, and how they'll help you get from the car, and they'll keep going if they can, and and it's all these things to put your mind at rest, really, and make you feel comfortable and safe, and then they pull up to the exit to the airport, and they go and collect their guns, and there are a lot of them. These guys are all very heavily armed, and and there are certain roads they won't take because they're unsafe, and you find your way to the compound, and they sit you down, and you have another half-hour security briefing, and everyone else got issued. The people we arrived with were workers who were staying quite a long time, and they were all issued body armor, but we weren't, because we were only here for a short period of time.
No,
so that's nice. So we felt special.
So you're taken to a house, a hotel, an office, what?
Well, the first thing we did is we went to the place we're staying, and it's a place called Ganamack Lodge. And the strange thing is that you come in through sort of double metal gates and into this sort of space that it's an airlock type space, big enough to hold a couple of vehicles, and then there's another vehicle entrance and another double door airlock sort of pedestrian entrance, and guys with AK-47s everywhere. And you step in a compound, and there's this old villa hotel. It's got about 20 rooms. It's an amazing garden with a fountain in the middle, and it's got a bar downstairs, and it's a restaurant, and you think, my goodness me, this is surreal. And then you walk in the front door, and this guy's got about, I don't know, 30 or 40 guns, sort of in gun cases along the front, the entrance to the hotel. He's got a German MG32, and he's got a Maxim machine gun, and just a whole lot of rifles that he's collected inside Afghanistan.
Gee.
Sort of very strange. And they've got a rule though: you can only have sidearms in the dining room. You can't have long guns, which is fair enough. I think that's reasonable. Yeah,
makes for a nicer dinner, I suppose.
Yeah, absolutely.
So give us a sense. I know we don't have as much time as we'd probably like to talk to you. Give us a sense of building a studio, or any of the. Are you doing transmitter sites too, or studios, or what's your mission?
Yeah, we drew the line that you're doing the transmission sites. Another contractor who is going to actually be installing the transmission equipment we've supplied, but we're doing sort of acceptance here in Afghanistan. So we're setting up racks of equipment. The big challenge is really, we walked into what was supposed to be an empty space that we could then install, an A and B studio and 3 production booths and a master control room. And to find there was kind of a working radio station there already. They were using sort of little Behringer mixers and sort of SM58 mics and a fairly cobbled together arrangement, but they were on air, and we've had to work around them, which has been very interesting.
Huh.
And
they must be a bit jealous. You're putting in the brand new IP audio mixing gear, and they've got a Behringer mixer.
Yeah. Well, that's right. They are the beneficiaries. So they're the ones that this radio station has started already, and they're going to be moving into these new studios.
Oh well, they can't be too upset then.
Well, it's strange because they weren't really expecting us. They didn't know we were coming. So literally, just container load full of equipment's arrived, and sort of we're trying to sort of fit it around them. And there's a pile of rubbish outside that's huge, but everything you need you have to bring with you, because you just can't find anything here. But the great thing has been the local technicians. I mean, Moby is quite a big organisation, but they've got these engineers. They what they lack in experience, they really make up for an effort, and they're pretty keen. But the whole experience has been like waiting for molasses. You just feel it's taken so long to do everything.
So when you build these studios, you said they'd be doing talkback. And now here in the U.S., I think we call that talk radio with callers.
Talk radio, yeah. Talk radio, yeah. Your local Taliban man telling you what he thinks about the situation.
So they'll be taking phone calls from local residents there.
All comers, yeah.
Wow.
But it's have a nice positive dialogue in a situation where you can't pull a gun and shoot each other. I think that's a good idea, really.
Yeah, yeah.
But, talking about TalkBack, we've just installed the new VX system here, and we were setting the VSET 12s up on the desk, and the guys were coming through to us and saying, or the manager saying through an interpreter, where does the SIM card go? And we're saying, I'm not sure what you mean. It's a multi-line hybrid. You could have up to 30 or 40 lines. And he goes and he looks and he nods and goes, yeah, okay, right. So where does the SIM card go? and we're trying to work out what the hell's going on. What do you mean SIM card? And then what it is this is a country that's gone from no telecommunications to cellular with no copper infrastructure.
Right. They don't know a handset without a SIM card.
Without a SIM card.
Wow.
And what they do right now, which is even better, we watch how they take calls to air, and they do it one of two ways. They either put the phone, the cell phone, which people are calling in on, and they've only got one, and they get next to it, and they put on speaker, and they put it next to the microphone. and to do background audio, they actually play a CD on a stereo in the room to do the sort of the background, the bed. That's their music bed.
Oh my goodness!
And you've got on one microphone, you've got the cell phone on speaker, and you've got the talent, and you've got in the background the CD player going. But what's interesting is that we're about to go from that to full element consoles and VX and sort of and we've got touch screens everywhere. So in actual fact, in the producer booths, we haven't got any mixers. We're actually using these mini Pathfinder panels with mixing panels.
Oh yeah.
And so they actually touch screen to actually move the faders, and yeah, it's going to be interesting.
Oh my goodness!
And all the what's been great is that the techs and even the operators and DJs have been coming in their spare time and on their days off to watch what we're doing and to try to help, because they're just so impressed with what's going on. Mm-hmm. And more than a little scared because, again, they still don't understand where the SIM card's going to go.
So you've been working with Rob Harling. Now he's an engineer, and you're maybe not an engineer, but you kind of know how things go together. What you said, difficult-wise, what's been difficult is getting little parts here and there that you just thought you'd have on hand. What has gone well, or what's gone according to plan?
Well, I mean. Everything sort of turned up, which was amazing. Mm-hmm. Eventually, because in actual fact, the gear we made sure was here a week or so before us.
Okay.
But on the way from the Bagram Air Base, where the equipment was actually brought into the country, there was a demonstration, and from the back of the truck, a carton just disappeared. It fell off, and it was a 3 kVA UPS.
Oh.
So, so how you drop a 3 kVA UPS from the back of a truck, you can just imagine sort of what was going on. But, so that was scary, that, just how we were going to get a replacement. But actually, it turned out this company called MEBS Global Reach, who did the transport for us, they just turned up with another one. It was really easy. But the frustration has been really just if you want something and you haven't brought it with you, just count on losing a couple of days for the smallest of things,
Wow. So when do you expect to have the studios finished?
Well, we're hoping tomorrow, in actual fact, that we'll finally have them ready to go to air. And just in time for us to do essentially a couple of days of training, mm-hmm. and then we're kind of going to let them loose. And yeah, it's going to be challenging for them, but it's such a difference. I mean, we've got some pictures of what they started out with and what they have now, and it's just.
Well, once everything is installed and you've left the site, will you have the ability to get into their gear remotely with their permission, so that you could maybe reconfigure something if you need to do that remotely?
Yeah, well, I think this is the great thing. The internet is very slow. I mean, it's very slow here, but still enough for us to be able to reach in and to because every device that we've installed essentially has a HTTP server in it.
Sure, yeah.
And we can jump in and do that configuration. But also, we've been successful in using TeamViewer to actually control the computers.
Okay.
You have to just take your time, but yeah, it's been enough for us to to sort of be able to reach out and you know, I've been having a lot of help. Igor Zukina, who's currently in Fiji of all places, is actually sort of reaching him remotely, like probably at the moment, and tweaking things and setting things up and doing config stuff for us. So essentially, although we've had a team on the ground, you know, a lot of it's actually been done from remote, which is pretty cool.
Wow.
And thank goodness.
So, Simon, we got to sign off with you. Any last comment about this project that you've taken on, building new studios in Kabul, Afghanistan, and doing it as part of a USAID project, I believe you said, and here you are, a New Zealand company in Afghanistan doing a project paid for by the U.S. Do I have that right?
Well, I think it's interesting because, you know, a competitive tender, and you know, we got the job.
Yeah.
And I think it was also because of the technology. I mean, but in the end, you know, it was an American company that American technology we went with. But it was interesting that you know, it needed to be this sort of technology to actually work. Because anything else, traditional stuff, then without the ability to actually sort of remotely configure and manage it would be really hard for these guys to cope. So it was a real point of difference.
Simon, I appreciate you spending some time with us, especially so late at night from Kabul, Afghanistan. Thanks for making the effort to be in touch with us here at TWiRT.
No problem.
That's our interview with Simon Jackson of ABC on This Week in Radio Tech. Pretty cool. Guys, you got any quick comments about that?
That was awesome. That was very cool. Yeah. I mean, just very fascinating how they do that. And I think he's right. I love the comment at the end. It almost had to be this kind of equipment to work. And I think he hit it right on, because in those kind of conditions, you know, the last thing you need to be doing is spending time punching, you know, 66 blocks or cron blocks under there, trying to get a traditional thing built out. You know, you need to do it efficiently, quickly, and with the least hassle possible. And that was a very good example of using modern technology to do that.
Yeah. Cool. Well, guys, let me take a break real quick for our other sponsor, Axia, and when we come back, we're going to talk about AM field strength readings. You think that's a yawner? You try doing it. It's very exciting, I'll tell you what. Hey, our program is brought to you in part by Axia Audio. If you haven't gotten your catalog yet from Telos, not hard to do. Go to the website. Any of the Telos websites like axiaaudio.com. You could even go to omniaaudio.com or telos-systems.com, or even we finally got around at Telos to getting an all-encompassing website. It's telosalliance.com, telosalliance.com. You can go on any of those websites. You'll have to find the link, but request your catalog, and look, you might just get to open up to this page right here. There you go. There's Leo in front of his Axia Element console, the very console that's running this show right now as we speak. Well, I've got good news for you. Axia is now shipping, finally. Axia is now shipping the IQ consoles, the ones we've been promising for months and months now. They're actually going out the door, and we're going to be fulfilling a ton of orders this month. And this means that radio stations and podcasters and other broadcasters around the world are getting their IQ consoles for under $8,000 US, a complete IP audio console with plenty of analog and AES ins and outs, and on the back, microphone inputs, mic preamps built in, an Ethernet switch built right in to the console mainframe, or to the part that goes into the rack, so you can plug in other Axia things to it, or plug in a phone, one of our VX phones that uses power over Ethernet. Plug in all kinds of stuff. Plug it into other studios. Plug it into 5 studios and have a core switch that connects them all together with the Axia IQ system, and soon to come along, the Axia Radius system, under $6,000 for an 8-fader console. If you saw the IQ console at the NAB show, you probably were impressed. We had like a 24-fader IQ console there, because you can bolt on to the sides. You can bolt on more faders if you like. And it was quite impressive. That console, under $12,000 for 24 faders, US dollars. So check with your local dealer. Go to the website, axiaaudio.com, and see who your local dealer is, no matter what country you are viewing or listening from. I'm really proud to be associated with the guys at Axia Audio. Incredible tech they're doing at Axia with unbuffered live audio over Ethernet. It's not compressed either. It's all linear audio, and it happens so fast that you can talk in the mic and listen through the headphones and not hear any delay on an Axia system. Pretty cool. And thank Axia for being a sponsor of This Week in Radio Tech. All right, guys. I think our next subject is AM field readings. And Mr. Tarr, you're going to take hold of this segment of the show, and we're just going to sit back and razz you. Right.
Fabulous. Hey, why is that anything new? Actually, how this came about was I had posted a picture of Tony taking our field strength measurements a couple of days ago, and Kirk said, you need to talk about this on Twit. So here it is. We're going to lay it all out. When you have a directional AM radio station, what a directional AM is an AM radio station with multiple towers where you create a certain signal pattern. So you want less signal in one area, more signal in another. You create what's called the directional AM pattern. Now, to do that, I won't get into the real technical details on how you make that happen, but the bottom line is, how do you know that that pattern is doing what it's supposed to do? How do you know that the signal is going over here where it's supposed to go and not going over here where it's not supposed to go? What you do is, at least every quarter, and more frequently if you have issues, is you take what are called monitor point readings. And what you do is, there's a piece of equipment called a field intensity meter, and you go out and you take these, you have radials that come out, just imaginary lines that come out from your tower site in different cardinal directions. And you go out, several miles out. And what you do is you go to certain points along those lines, and you measure how much audio or how much RF signal you're getting in those various areas. And how you do that is you use this field intensity meter. It's a very sensitive AM radio. There's a picture of it right there. That's a very common Potomac Instruments meter. And unfortunately, I had a video, I didn't get a chance to edit it up, of how you actually use this meter. But what you do is you go out and you file with the FCC when you build these directional systems. You file certain geographical locations with the FCC where you monitor your signal. And the reason you do that is you find places where you set up these monitor points, and you can do a very consistent year after year after year measurement. So, for example, if your signal is 10 microvolts per meter at this one spot, that should be what it is every year, every quarter when you go to take these measurements. And that's how you know that your directional system is doing what it's supposed to be doing. Now, how you come up with those points, I won't go into the scope of that, but essentially, when you design the system and you create these lines and you find where your nulls are supposed to be in your signal, where the areas where the signal should be the weakest, you take all these measurements, and that's what gets filed with the FCC. And those are the numbers that they use to verify that your signal is going where it's supposed to be going. So every quarter we go out and we take these measurements. Sometimes it's by a fire hydrant. Sometimes it's, one is in the middle of a cul-de-sac, and you go out with this antenna monitor and you measure the signal strength of your signal, both in, both if you have a day pattern, night pattern, whatever it is. But essentially these are filed with the FCC, and that's when you know if your signal is in or out. And that's where it becomes fun. For example, if you go to a monitor point and the signal's always measured in a measurement not to exceed. So, for example, on your license it'll say monitor point number 2. From the radio station, go 2 kilometers to Smith Road, turn right, up 3/4 of a kilometer to the front of 3702 Smith Drive. The field strength at this point should be 25 microvolts a meter. Well, what that means is that the measurement should not exceed that amount at that spot. Where the fun comes in is if for some reason it does exceed that. That means that there's something wrong with your directional array. And that's when you go out and you make some adjustments and you try to figure out what the problem is. So essentially what that is, it's a good way to measure the performance of your AM array. And again, you're required to do that every so often. In fact, I still believe the rules require, if you have an AM station, directional station, you have to have one of these devices in order to make sure that it's working. But you can get into things like, for example, a few years ago, about 5 or 6 years ago, when I first took over in Milwaukee, our directional AM station there had one monitor point that was consistently out. It was consistently high. And we couldn't, it was very, very high, and it was along the entire radial. So every point along that line, the signal was much stronger than it was supposed to be. So we hired an engineering firm to come in, and we decided at that point, after looking around, that the components in this antenna system hadn't been touched since it was built in the 60s. So he and I spent the summer rebuilding the entire system, the phasing cabinets, all the antenna units, and we went out and redid all of the monitor points to make them more accurate, because these monitor points were also 40 years old. So, for example, where they said on the side of the road in a ditch was a school now. So, you know, it's very hard to get consistent readings if you don't know exactly where these things are supposed to be. So we went out and we came up with some new monitor points. We used the GPS, so now we have GPS coordinates, so you know exactly the spot that you're supposed to be standing to take these measurements. And you know, with the re-engineering of the antenna system, it's a lot more stable, and we can reproduce those readings every time. And so, you know, that's, you know, it's a good tool to make sure that your signal's doing what it's supposed to be doing and not going where it's not supposed to be going. And so it is the one thing I enjoy about it. It's great on a nice summer day. You spend a few hours out just driving around and you know, with the monitor taking your readings. I have had some situations where people want to know what you're doing, because you're standing out there with that big meter in your hand.
That meter, I bet, looks like some
kind
kind
meter, of... and big old brown meter in your hand, and you're spinning around in circles taking readings, and you got a clipboard, you're writing things down. And one person walked up to me and asked me one time, what are you doing, sir? And I explained, you know, well, I work for the radio station, and we're checking signals. And great, because I don't get the radio station here, and it really drives me nuts. So could you do something about that? So we've had that before too. But it is.
I'm sure we all have stories. Good. Go ahead, Chris.
A FIM is really, you know, with a directional AM doing these monitor points is becoming a lost art, unfortunately.
And again, you just use the acronym FIM, and that stands for
Field Intensity Meter.
Yes, and so that's a lot of syllables. So we engineers say a FIM.
Right, and that's the thing, is it's interesting. A lot of the new guys coming into the field have never been out doing that, you know, and haven't had experience going out with a FIM. And that was the picture I showed the other day. I was teaching Tony for a couple of years. You know, he'd ride along with me and take notes and stuff. And, you know, I always liked doing it. So I was, again, delegating, you know, so I always did it myself. He's like, this time you have to let me do it. I have to learn how to do it. Like, you're right. I have to let you do it. So, you know, that's what we did, is I went out and I showed him how, because there is a trick to it. You know, the antenna on the FIM is very directional, and part of of taking the reading is turning the FIM around until you get the strongest signal, and that's what you measure. And there's a very definite null, because the receive antenna is very directional, so it only receives, you know, the strongest signal in a certain direction. And as part of that reading, you have to turn until you get the maximum reading, and there's a calibration procedure you do before you take the readings. So it's not there is some art to doing that and getting accurate readings.
And I should point out that these FIMs, field intensity meters, they're calibrated, and their calibration is traceable back to what used to be the National Bureau of Standards, what's the National Institute of Standards and Technology now, or Science and Technology. So, and inside them, they have a calibration oscillator that lets you indeed check the calibration of the box. There's something that's interesting, I think, about taking these a lot of interesting things, and we could do several shows on this subject. And by the way, these are the measurements you're talking about are for AM, although they make similar devices for FM, but generally we don't use them for FM unless we're trying to find some other problems. But one thing interesting, you mentioned that you have to align the meter for the maximum signal. And if you turn it 90 degrees for the minimum signal, you should have at least 10 decibels less signal at that point. And if you don't have 10 decibels less signal, or more than that, less than your peak, that's a pretty good indication that the monitor point may not be good. There may be some source of re-radiation that's local to you. You might look overhead and see, oh, there's power lines right over there.
Right. Well, and that's the other important reason why over the years you do these field intensity meters, because things change. Cell phone towers go up, power lines go up, new buildings pop up, and these things can all re-radiate your signal. And you know, so those monitor points may be way out, and it may be due to re-radiation. And like you said, that's the nice thing about the directionality of the meters, is you can tell if you're just surrounded by signal, there's a very good chance that there's something nearby that's re-radiating, and that's going to cause issues not only local, you know, not only in the local area of the interference, but it could, if it's a big enough structure, cause skywave interference as well.
And if that re-radiation point is in a major lobe of the at the AM directional station. Let's say that the AM directional is supposed to be putting most of its power over a town, and let's say that town is to the north of the transmitter, and it's not supposed to put any signal to, let's say, the east and the west, due east and due west. We have a minima at those points. Well, if there's some new tower in the major lobe, let's say a new cell tower, that is tall enough to act like a resonator, it re-radiates that signal. If it's in a strong major lobe, it can re-radiate signal toward the areas that you're supposed to have minima. And that way, you'll exceed the power allowed at your monitor point. And by the way, those monitor points, that is a quick and dirty way, or it's required, to see if I'm not putting out more than X amount of power at this location, then I can assume I'm not interfering with the radio station 800 miles away that I'm not supposed to interfere with.
And there's a whole process if you want to verify that, because remember that's just a point on a line, and again, that line, there's a total on that radio on that line of all these points that you measure, and a total in that direction that you can't exceed. That's just one point on a line. So, for example, you may, in troubleshooting, your point may be high there, but go to the others, and it may be that those are low enough where in total you're still below for that line, below the maximum amount of RF in that direction. So, it is a fantastic tool in terms of troubleshooting and making sure that things are okay. And not only that, sometimes there's a situation where maybe your antenna is tuned, your antenna system is tuned a little too tight, and maybe you don't have enough power going in that direction, and you can loosen it up a little bit because of a change or something like that. So not only can it help you keep things down to where they should be, but sometimes you find a situation where they're consistently low, and you know what, I can make some changes here and get our signal a little better in that direction.
We've got to do a whole episode on this subject, especially maybe a War Stories episode where we can tell about taking field strength readings. Hey, I was going to ask Marcus, what do you have there?
This is my FIM. It's the 41, where it only does the broadcast range, but it looks cool too.
I thought that was the 21, but okay, it could be the 41.
Is that the 21?
Yeah.
I'm not sure.
Those things are kind of expensive nowadays, aren't they? On the order of $5,000 or more for the simpler one, and $7 or $8.
You can't even. I don't think you can buy those anymore. Potomac doesn't make those. They sell digital ones now.
Oh,
the
digital ones. What, about $10,000? Someplace in that ballpark.
And by the way, good luck getting those calibrated in a hurry. It's not going to happen.
Yeah. Now you can, if you've got several people out making field strength readings, you can calibrate them against each other to make sure that they're all matching. In fact, I had 2 of those units when I was doing contract engineering full time, and one of them, the calibrator didn't work. So I always took both of them with me, and I would calibrate the first one, but it was kind of older and more rickety, but the calibration worked. And then I would take the newer one, which it was great, except the calibrator didn't work, and I would just calibrate it to be exactly the same field strength at that exact same point, and then I considered it calibrated.
When you're actually, filing anything with the FCC, good luck using that as the calibration standard on your application.
Well, I don't know. I thought people did that. I thought that was a standard. And in fact,
that is for quick and dirty, but you really are supposed to produce the when it was calibrated and by Potomac and certified as being calibrated. And you're supposed to. I believe they recommend that you do that every 3 to 5 years.
Although I know I have used FIMs that hadn't been calibrated in 20 years.
Oh, I think they're usually reliable enough where that's really not that's not the case. But when you are dealing with AM directionals, especially if you're building them, it's probably a good idea to make sure that your calibration's dead on.
So Tom, how many field strength meters do you guys have at WOR?
Actually, we have 2, but we only have 3 monitor points for the directional we have. And, Chris had mentioned before about re-radiating structures and a building goes up. It's a lot of fun doing measurements through the center of Manhattan.
How do you do that?
Carefully. No, with the old WOR array, when I first started at WOR, we had to retune, we broadbanded the array, we changed some of the tuning networks, so we had to go out and we had to proof it. Went through Manhattan, and there was this one corner, I believe it was on the corner, I think it was 11th, it was 11th Avenue, I forget what the street was. But I went over there, I took the field strength meter, And let's make believe this is a field strength meter. And the transmitter was over here. So I aimed it at the transmitter, and I got a reading. And I went to calibrate it, so I turned it 90 degrees off. And I had the same reading. And I stood there in the middle of the intersection. I stood there and did a 360.
Yeah.
The meter didn't move. However, this was a place on the proof. I had to take it, and it was reading exactly what it was supposed to according to the paperwork. So apparently that's where somebody measured it years ago, and it had never changed. And Chris had also mentioned the people wanting to know what he did. At one point, we had a monitor point change, and one thing we should mention that if a monitor point value changes, if it's out of tolerance, or if it goes way low, you take a look around. In this case, there was a bridge the state was working on that was adjacent to the monitor point, and they had it all covered, and they had extra steel and cranes and stuff around. And if you have a monitor point out, you don't panic. What you do is you actually go out and you run one of these invisible lines Chris was talking about. You run the radial, and you do what's called a partial proof on the radial. And you compare all these readings, with the exception of that monitor point, and see if you're in. And in this case, it was. And I said, okay, well, I'll file with the commission to get a temporary monitor point until the state's through. So I found this one place. We went out and measured. And I must have been back there 3 or 4 times because I was making adjustments on the phaser and coming back to see if it was acting the way it was supposed to act. And finally, this guy comes out. And now I'm standing in the middle of the street. I'm nowhere near him. And he looks at me, and he's, what are you doing? I told him, gave my business card, get the hell out of here. I said, well, sorry, but you know, I'm doing these measurements. And he says, well, I'm going to call the cops. And I said, knock yourself out. So, 2 minutes later, cop shows up, and I'm standing there, and I'm taking a reading, and the officer says, what you doing? I said, oh, I'm from WOR, handed him my business card. Oh, gee, I listen to John Gambling in the morning, blah, 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 blah. And we start shooting the bull, and I told him what I was doing and such, and he goes, I said, I'm on a public street. I said, what's the problem? He goes, I don't know. So the guy came out, and he looked at the guy, he says, what's the problem? He's out here with a meter. I looked at the cop, and I said, I bet you this guy's stealing cable and thinks I'm from the cable company. He went white as a sheet and disappeared into that house so fast, he left a dust cloud when he went into the door.
Oh, we got a million stories about that, and some of them are quite funny, and a few of them are pretty scary. Hey, Marcus, you've got a directional AM there in California that you take care of, right? Or at least
up in Bakersfield area. It covers all the way out to the coast.
Oh, my goodness. So you just take monitor points, or have you had to run a radial for a long distance?
Well, no, we just have done monitor points. We haven't had to really do any radials yet.
You haven't lived. Oh,
I know.
I do have disappearing monitor points, though.
When we did our we redid our tuning and phaser and ATUs and stuff and redid partial proof, it was August and I'm out in a swamp, inhaling mosquitoes, taking readings. Oh, it was fun.
Yeah, the mosquitoes, that's fun. The dogs nipping at you, the people coming out of their house with shotguns. That's fun. And I love you mentioned the monitor points and how they're described, and the description of the monitor points becomes, I guess, legally part of the license, and the old ones are funny. Like, well, you take this monitor point here next to this gray house where this old yellow dog lives. Yeah.
Yeah. Oh, there was a lot of those. Again, when we redid ours, literally there was one. It was like side of the road in the ditch or whatever, and there's this huge school there now. There's no ditch. The road's like 4 lanes now, and they show this picture from 1958 or something with a picket fence, and I was like, how do you figure out? We just had to guess. We're like, okay, well, we think it's here at the fire hydrant in the parking lot. It's all we could do.
10 paces from the large tree.
Guys, once again, we are out of time. We've gone a little bit over our hour, and poor Marcus O'Rourke, he has hardly gotten a word in edgewise, and gave us some great advice at the beginning of the show, and we're going to have Marcus back on again to tell us more about balancing work and balancing home life, because that really is critical. Marcus, thank you very much for putting up with us for an hour and giving us a little bit of advice.
Well, thank you for putting up with me for an hour.
Well, we will have you back on, and I noticed you've got your ham call sign there, so you are an amateur radio operator.
I am. I'm a tech, but I need to upgrade to general, at least.
Right. And if anyone wants to get in touch with Marcus, he did say it's okay to put his email address on his lower third, so there it is. Hey, you must be the IT guy.
I run the email.
No, nobody gets M. Nobody gets a single letter except the IT guy. Well, thanks a lot, Marcus. Appreciate you being with us from Santa Ana, California, and we'll look forward to having you on again sometime, okay?
Well, thank you again.
All right. Chris Tarr from Muckwanego, Wisconsin. And where can we participate in engineering talk with you?
Broadcastengineering.info is the site, and it's the virtual engineer.
All right. Thanks for being with us very much from Muckwanego, and go spend some time with your family. Make that balance work.
I'm on my way.
All right. And Tom Ray has been with us, too, from the Hudson Valley of New York. Tom, thanks very much.
Hey, thank you, Kirk. And I'd like to just tell Marcus that if you are going to upgrade your license, I'm the VE team captain for the Orange County Amateur Radio Club, and July 1st is when the general class question pool changes, so make sure you buy the right book. Don't buy the old book. If it's anything like the changes in the tech last year, it's going to be a heck of a lot more complex and a lot more technical than the old book is.
Well, when I get to New York, I'll look you up.
Oh,
Orange
please.
County, California.
I love it. Orange County Amateur Radio Club in both places. Every time you do a Google search, you come up with you guys first, us second. It's wonderful.
Then Florida third.
Yep.
Hey, guys, and next week we've got another guest on the show. It's Bill Putney, and some of you know him as Navion in the chat room. Bill's a pilot, and he's also an engineer. He's just built a radio station in Washington State. So we're going to be talking with Bill next week on This Week in Radio Tech. Thanks for joining us in the chat room. Appreciate you being with us as well. You can always get the shows and look at the show notes and get the audio or video, subscribe or watch live. If you just go to twit.tv/twert. twit.tv/TWIRT and look for us there and all the other places that we appear. We still have the website, thisweekinradiotech.com, where I still post links to the audio version of the show to keep it consistent for you folks who have been following us there for years. Thanks to Burke very much in the Petaluma studio for switching the show tonight. Appreciate it very much. And we will see you next week on This Week in Radio Tech. Bye-bye.